Yes, at the beginning of this year, I took a new position of business development around the Internet of Things. Nevertheless, 3D printing is a passion that I'm following since a few years now, and that I'm trying to transmit to every colleague that I can, and then trying to inspire. That's why I welcome you all to the truth and myths of 3D printing. In the last few years, you were all able to observe how news about 3D printing have moved from technology magazines to normal newspapers. Here you can find some of the extracts of different titles from different newspapers of the last month. Some of you who are following the news might recognize several of those titles. Before being able to understand the truth and the myth around the 3D printing, we will need to get an overview of the 3D printing technology. This will support us to understand where it comes from and what the potentials and the limits of this technology are. Therefore, we will discuss a short introduction of the definition of additive manufacturing, and we will take a look at the brief history as well as an overview about the technology and involved processes. We will see how the products are developed for AM and how they are manufactured, including the preparation, creation, and finishing of the parts produced for AM. Additionally, we will take a look at the different applications showing the potential of these technologies. Further, we will discuss which limits needs to be taken into account when you are producing parts for it. Finally, the streams that we are currently pursuing by High Tech within the group will be presented, with the hope that I can inspire you, some more colleagues, to join the high-tech journey in the islands of the customers. What is additive manufacturing? In fact, it's not an easy definition, but if you look to the easiest way to see it, you can understand it better. First of all, 3D printing uses several processes. There is not only one, and which create the three-dimensional structure, like using, for example, extrusion, jetting, sintering. It is an additive process that builds parts layer by layer. Hence, it's most often also termed as ALM, which means additive layered manufacturing. The part is produced from a digital input in a certain format that is created with a specific design software and then translated with another software within the machine. Of course, the printer itself is clearly a robot. In the picture, you can see in detail how it is produced, for example, for the principle of laser sintering. Let's have an overview about the brief history. In the late 80s, additive manufacturing was mainly referred to as a rapid prototyping. During my internship at RWTH Aachen, I can remember having participated in a company called Spacecast. They were creating with rapid prototyping what the mold, the negative of the structure they wanted to cast. It was very funny and already in 2000 a very interesting experience for me. The aim of the technology was to create cost-efficient prototypes in a rapid manner. The first known patent application was filed by Dr. Kodama in May 1980 in Japan. Unfortunately for him, the full patent specification was subsequently not filed 1 year after, so that his exclusive rights to this technology had ceased. Considering that he was a patent lawyer makes this fact a little bit funny, or maybe dramatic, depending on the point of view you look to it. The first apparatus was based on the stereolithography. I really hate it. I prefer to call it SLA. And invented by Charles Hall, a co-founder of 3D Synthesis Corp. In 1983. The patent was implemented in 86 and the first commercial RP was released for sale in 87. In the same year, 87, an additional patent was filed by Carl Deckert, introducing selective laser sintering. The patent itself was issued 89 and was acquired by 3D Systems later on. In the same year, Scott Crump, a co-founder of Statistics Inc., introduced an additional patent for fused position modeling. This patent issued 92. In Europe, a German company, EOS, or EOS, GmbH, founded by Hans Lenger in '89. We heard a few weeks ago that this company was created in a garage, like a lot of other ones we might know. Focus on the laser sintering itself. The company sold its first machines 2 years later to BMW. Yeah. Together with Electrolux Finland, they have created the direct metals laser sintering process. During these years, additional manufacturing technology emerged: ballistic particle manufacturing, laminated object manufacturing, solid ground curing, and finally three-dimensional printing by Emmanuel Sachs. In the early 90s, a good number of companies in the field of rapid prototyping emerged and began competing in the market, but only 3 of them were clearly dominating it: 3D Systems, EOS, and Stratasys. Between the 19th and the early 2000s, several new technologies emerged, and industrial solutions for tooling, casting, and direct manufacturing applications were established. This created the necessity of a new terminology, namely rapid tooling, rapid casting, or rapid manufacturing. Several companies continue to introduce additional technologies, like electron beam welding, so that over the time, more and more general definition was needed. As a consequence, additive manufacturing appeared, or as we know it today, 3D printing was born. Both terms are used very often today. In the picture you can see 2 links, the usual ones: Wikipedia, where you can read a lot, but as well dpt.com, where you will find really nice and more detailed adventure of 3D printing. As you can identify in the picture, you see a large number of additive manufacturing processes are nowadays available. The main difference between the individual processes are in the way the layers are deposited to create parts and in the materials they are used. Some of the melt or soften materials to produce the layers, like for example using selective laser melting or directed laser sintering, and so on and so on and so on. While other cured liquid materials using different technologies, like SLA. With laminated object manufacturing, thin layers are cut to a shape and joined together, like using, for example, paper, polymer, or very thin metal. Each method has its own advantages and drawbacks, which is why some companies consequently offer a choice between powder and polymer for the most materials used to build an object. The main consideration choosing a machine are generally speed, cost of the 3D printer, cost of the printing prototype itself, cost and choice of materials, and color capability. Printers that are able to process metals are rather expensive. In some cases, however, less expensive printers can be used to make a mold, which then used to make metal parts, like I told you at the beginning, for space cars. In the table you will find a categorization provided by Gartner, who performed a really intensive survey in 2013 of the technology. There you will find the process and also the prices for different printers. You have the original one with the ME, so the material extrusion, SLA, binder jetting, the material jetting, then the ones with the metal production, or the new ones. Multi-jet fusion does not have a price now. This is an announcement of HP that we are waiting in the middle of next year. So now we have talked a lot about the things around the past and etc. And we are understanding the origins, the general scope, and the different process of the 3D printing. Let's see how to develop such a part. Let's start from a fictitious situation where we have to integrate a structure that connects water pipes, for example, with the main structure of a product. This you can see represented in the first picture. If we could manufacture such a connecting part in a traditional way, we will use the standard parts from a supply chain that we can assemble together in order to install the water pipe. In this case, I will propose to choose a sheet metal construction in order to provide a lightweight structure. You can see such classical structure in the figure 2. And if you count the different colors, you will see these are different parts. We are talking around 10 different parts with the connection parts like screws, fasteners, and etc. In the second phase, we might then think, oh, it's too complicated for the supply chain. We should create something more optimized. And then you can go on and think about improving the manufacturing chain in reducing the parts. And this is the third picture you can see. However, in an AM part is desired, we will have to take some steps back and review the development of these structures. In fact, classical manufacturing constraints as they come along with the sheet metal manufacturing can be entirely neglected. When using AM, the design engineer takes up the role of a sculptor who is following the flow of the energy transfer due to the loading through available space. As a consequence, first of all, we need to define the space that is available and that can be used according to the requirements of the installation. This is also called the design space, and it's depicted in the fourth figure. It is clear that we are now talking about structural optimization. Once the design space is fixed, we have to decide which parts of the design space can be changed and which parts may not be altered. In the fifth figure, you will see several constraints being applied to the design space, which is where the structure under investigation will be attached to the actual product. Lastly, we will have to define the applied loads as well as the interruption point of the loading, who are represented in the sixth figure. Once the model has been established, it is submitted to a topology optimization package of your choice, whatever, of this drug, and etc., etc. Typically, the results of a topology optimization lead to raw structures that resemble to a bionic design, and actually very often have much in common with structures as they evolve in nature. The reason is that most of the time those software packages are using very special evolution algorithms that take the nature evolution in account. It is then the task of the designer to interpret the results and come up with a design solution that follows the optimization result as closely as possible. However, weeding out sharp corners, notches, and the like during this process step, as they are typically for the topology optimization result. The above figures show two different design solutions established by two different individuals using two different design packages. While the design solutions are very similar as could be expected, they nevertheless contain some detailed deviations, which goes to show that the AM design process is highly susceptible to personal interpretation and is thus difficult to automate, also due to the general complexity of the topology optimization result. After you use mechanical simulation and or hand calculation tools to verify if the given requirements concerning stresses, displacements, vibrations, and so on and so on and so on are fulfilled. Generally, it will be necessary to repeat the process steps, optimize, and design several times before a design is established that satisfies all given requirements. It is interesting to remark that the given example here mainly consists of hollow tubes that were founded to be an ideal solution in the light of the specific constraints that were given to this problem. It is clear that if such a structure was manufactured by using classical means, it would be much more expensive and would take much more longer to be manufactured, which again shows the clear advantages of 3D printing when it comes to highly optimized and sophisticated design. Nonetheless, even though 3D printing has many distinct advantages over classical manufacturing process, during the development of parts you have to take also the limits of the 3D printing process in account, the systems and the materials that you want to use for the production, just like when you want to use a classical manufacturing method. Also here, you have to clearly understand what needs to be prepared and how the a part is produced and how it needs to be done during the finishing of the part. Let us imagine for 1 second that you want to create the block parts that we have seen in the slides before. with, let's say, directed metal laser sintering. You will have to take into account that you need to add cooling support. Like, for example, you can see in the picture of the GPI prototype. To ensure that the strains within the structure produced by the heat of the laser are dissipated during the cooling phase. Additionally, we will have to consider that the powder that sticks within the hollow tubes needs to be removed after the part has been manufactured. So you will need to drill holes to evacuate the power, and you will also have to take into account the cutting phase of the support structure. And also additional surface finishing to ensure that the quality is the same as with the other ways to do it. During the manufacturing, it is also important to ensure that the production space within the printer itself fulfills the adequate requirements, like maximum volume, positioning of the structure, evacuation of powder during the production phase, and many others. What is very clear is that you cannot simply change the process, 3D printing method, the system, the 3D printer itself, and the material without having a clear impact on the way you manufacture your part. It is also the case that just because you use the best material, that you will automatically achieve the best result expected with different printers. On these slides you can find some interesting links to understand the different process and also kind of materials that are available. I really can recommend you have a look on it, because there are really 8, 9 several processes, and all of them have different views and different things that you have to take into account. I strongly believe that most of you might already read a lot about 3D printing, 3D printed applications, or even have seen some of them. As already mentioned in the history introduction, the automotive industry was one of the first users of this technology for their rapid prototyping topics. One you can see here in the 3D system. But over the years, medical and dental applications have emerged rapidly and have been strongly industrialized with strong standards approach and highly products behind. Furthermore, in the last months, you could see a lot movement concerning 3D printing around the aerospace industry, considering that significant investments by the re-owned players like General Electric Aviation, Airbus, RUA, and other OEMs in the aeronautic field. But 3D printing has not only found its place in the traditional industry, it moved to fashion, art, jewelry as well. And finally, the high potential of such thinking has made its way to the biotech industry, where you can find solutions for traditional medical applications and even in the food industry. I can only recommend you to watch some of the TED Talks that are really very interesting and informative and also very inspiring. For example, Antonio et al. Is talking about how to print organs. They're already talking to commercialize kidneys and theories for in the 2 next years. And Andres Forgas elaborates a method how to print a steak in the future. Imagine that one, very near to the Star Trek beamer. In the amount of the news that are produced during the day around additive manufacturing, and believe me, I'm really looking to a lot of them each day, it's difficult to distinguish between truth and myth, or what I would call vision. As I already mentioned, Gartner has done a very intensive survey around the 3D printing, and they clearly see the increase of the printer sales in the next 5 years. If you see to this picture and understand the numbers they will go to sell, it's awesome. But despite what the most popular believe, it will not be home printers before the next 10 years, in my opinion. During the last few years, a strong push by the media around this topic make a huge hype. It was proclaimed that 3D printing offers no limits for your ideas and business models. The hype is still present, those already declining and slowly reaching more realistic outlook, and still push manufacturers to buy a printer without really knowing which return of investment they can hope to expect by investing in this technology. We were 2 weeks ago at EOS companies. And first sentence they say is around sales was, sales is not an issue. That means a lot of people come, buy, then what do I do with that? After having such a machine, in the production hall, the manufacturer starts to understand and discover that this technology cannot produce whatever you want, easy and rapid. Yes, there are limits, for sure, that need to be understood and clarified. From that point now, they focus on the value that they discover and exchange a lot to learn from the leaders, experts, 3D printing communities in general. Passing through this phase, they begin to produce their first ideas by trying to build the same product, or maybe already try to optimize them. They test the structures, they discover the difference they have to take into account. They start to build standards, adapt the production, and manage the lessons learned. Only they are able to really buy more printers and roll out a revolutionary industry if they pass all these phases. The opportunities are really clear. Through the several processes of manufacturing, you can use whatever you need to produce your product and to bring a really revolutionary new design with movable parts and etc. etc. You will need really to have an adapted production process, have understood and adapted and implemented the technology. Another myth we really talk a lot is the democratization of manufacturing. And there are two very nice examples. One of those is in the Netherlands. You can ask our colleagues from the Netherlands, Sogeti. There is a huge community called 3D Hubs that has been started and now spread over the world. Today, when you log in this community, every person is able to access to the printed parts. It does not matter if you are an enthusiast hobbyist or an entrepreneur who wants to start with a small production. So you are able to upload your design, 3D design, choose the print location, get in contact with your local printer service supplier, and even go and have a look how it is produced. This community keeps growing more and more with a strong sense of cooperation. This is awesome. A second good example is a pilot project that UPS started with 6 locations at the end of 2030. They wanted to test 3D printing service like they are doing it for 2D printing. Instead of transporting the parts from one place to the other one over the UPS logistics and infrastructure, UPS receives directly the digital information and prints the parts. They were so successful that 1 year after they decided to open 100 additional locations in the United States. And if you have a look to the picture and read the commitment of Michel Van Styk, the Vice President of Marketing and Sales, you will understand how much money is behind. Let me give you an overview about the streams we are pursuing in Sogeti High Tech division. We also wanted to give you this small overview of the ongoing stream because it's spread around the community. It's in France, Germany, India, Spain, and UK. We are focusing on improving the methods and also the tools by creating processes taking into account all the different aspects of the pre-development manufacturing. And to show these strengths, we also started to show these strengths. We started to show how we developed and we are creating. So we decided to take some of the pilot parts and simply taking old examples where we were doing the old optimization for old process, with old manufacturing methods, not old but the traditional one. And we are also trying to follow kind of pre-selling of these parts to the customer. Another stream on the reference we are following up is the award. Additionally to this stream, we are building a strategic partnership with a 3D printer builder. We hope with that to get the right understanding of the production and at the same time be able to support the test qualification and the material qualification of the test qualification of products and the material qualification itself. In the know-how management stream, we want to use our strengths and create a culture of centralizing and spreading know-how. We are used to train colleagues to become train-the-trainers, and we are able to create very strong technical trainings that inspire and activate all motivation. And this is a thing that we really want to improve more and more. Today, the colleagues who are managing this is Christian Mitterstedt in High Tech Germany, Franck Bacou in High Tech France, Pierre-Yves Maillard in High Tech France, and Jeff Lake in High Tech UK. At the end, I really wanted to show you as well some links that I'm using daily basis, and also some videos that inspire me a lot when I was looking to them, and some very interesting articles. I can really tell you, please follow the blog of Pete Basilia from Gardner. He is really a passionate guy around the 3D printing. So, and this was my part of the presentation. So if you have questions, I hope I will be able to answer to them.
Perfect. Thank you very much. Very interesting. And it's a very broad topic. It seems to touch more and more. It started in perhaps several industries, and these days, as you mentioned, it starts to touch more and more industries, from manufacturing to now retail, and who knows, consumer goods, or any type of customer that we have to deal with. Early on one of your early slides, Thierry Daumier asked something about the cost that goes into this and the decision making, and that kind of triggers me. Is how low are these costs becoming? Because we have gotten used to manufacturing being a massive scale at very little cost. Is 3D printing anywhere near that, or is it still relatively costly and relatively unique to do that?
In fact, in the Gartner survey, they were talking that in the R&D, when you are in the R&D phase, you can have a saving of around 3.7%. In the manufacturing, it's something around the same amount, 3.5%. In the supply chain, there is even 4.1% saving cost. The cost saving are implemented when you start to understand how it works. Most of the people are thinking that you can use a 3D printing metal, titanium, which is very expensive, by simply produce a better part. But it's not the case. In fact, it is how can I reduce the whole process. If we are, as I showed in the example, for example, of this one part we are creating, we are talking about an assembly with 10 parts. You understand? That means in the pre-development you have to verify these 10 parts. You have to send it to your PLM system. You have to create nodes. You have to make the infrastructure in SAP. You have to make the commands for so much pieces, and etc. etc. You have to have 2-3 persons maybe that assemble these parts. You have to have more screws that are necessary, and etc. etc. That means by using, in this one case, for example, the integration philosophy, you reduce all these parts in one part. You are able not to reduce the price of the part itself, but to reduce the whole chain of production, from the pre-development until the manufacturing itself, and in certain cases even the after-sales.
Huh. Okay. That brings the discussion to a different level, at least. If anybody else on the call has any questions, you can ask them by unmuting yourself and just speaking up. This is a very equalitarian environment. Everybody can speak if they want. Or if you're somewhat shy, you can use the chat function that you can find if you open the little green bar on top. You can click chat, and there you can ask your question there. I had another...
Yeah, I have a question.
Oh, go ahead.
So, we've sort of lumped 3D printing as at sort of same level as Internet of Things in the way it is going to change perhaps manufacturing or have an impact on everything that's happening basically in technology. Based on your presentation, I am thinking actually that that perhaps there is going to be a big impact in manufacturing, but actually that a lot of the hype around 3D printing is complete nonsense. Can you comment a little bit, because it seems actually quite complicated to really make this work, and all of this talk about printing houses and whatnot, it seems a little bit far-fetched.
I would say in the one sense yes, and in the other one no, because in fact it is a revolution. You are able today to make a lot of integration with the materials we are used to. If you were looking to the aerospace at the moment, they are trying to use in new airplanes new materials like composites, yes, to achieve better results, better efficiency of the airplane. But still very unclear the methods. They are creating these parts in the old way, and etc. They are restricted to very strong limitations, and so on and so on. With this possibility to democratize your manufacturing, you can imagine the following scenario. You are, do you know the hearing aids that you put in your ears when you become a little bit older and you cannot listen to? There was a funny story of Mr. Gartner, who was making the webinar from Gartner. He was telling how it is done. It is done in one day, and this is only possible because the service supplier is near to it, and these parts are the desktop printers for these parts are already very small and do not cost so much. So in a certain thing, yes, you can democratize. You can create such hearing aids in one day, mixing the whole traditional things like having a typical electronic unit with a button, the micro, and and then use a mold that you put in your ear, scan it, put it in the digital form, print your perfect hearing aid that you can implement directly in your ear. It feels comfortable, etc. This was not possible before, and this will come more and more. And there are some very interesting things that people are producing more and more in the world from ideas. So there are people who are constructing their own protest hands. I don't know if you have seen it. This is not a myth. This is true. These are people who are connecting to the 3D hubs, and they are working with the communities and supporting each other to make a very simple design who is not so costful, and then bring it to it. But when you are talking about, yes, let's say revolutionize a house construction, they are at the beginning now. They are far away to be like, for example, in the medical and dental branch. But if the evolution keep on and keep on, they will make their sense, because you need, as I told you during the presentation, you need to understand and this technology, and then you will be able to see where is the value, and then you focus on the value, and then you are able to make more money than before.
Okay, cool.
I hope I could answer to the question.
Yes, that's interesting. Thank you.
Any other questions out there? Other people in the group who want to know about their specific questions? All right, I have one, which is, it's all looking good, and technology is miniaturizing, and we're learning how to do that, and there's a market for 3D models, and we have new materials, and everything's great and wonderful and rosy, and yes, there's a revolution brewing, but what are the, I would say, obstacles? What are still the hard things? Why is it not common yet? What are we still waiting for? Are there great inventions, or is there something that stands in the way of this growing, or is there a risk that perhaps it stops at some point?
As each technology it is the human factor. When we were introducing this new technology to our colleagues, the designers here, who were used to the traditional way of constructing, of modeling, of designing, they were very lost at the beginning, because you have to change your mindset. You know, when you are doing a design of a cube, yes, you have your 3 dimensions, yes, but when you become an artist, you have to think different. And this is the biggest and the hardest change. It's the mindset of the people. A lot of people buy such a machine and they say, yes, now I have one. And wow, what now? Yes, they have to learn to get a habit to the machine, to understand how it works, and then to see the limit, and then they can start to make it. And this is the issue that I try to explain with the picture. Let's show me once more. This one picture here. If you, at the beginning you have this motivation, you know, then comes the frustration. And as soon as you understand, okay, I have to accept that it's not possible to do all the things, let's focus on the value, and then I can go on. But it is the human factor. The people have to change their mindset.
Is to some extent this trajectory comparable to the introduction of industrial robotics, where, you know, in the beginning of that trajectory everybody wanted a robot, but then they couldn't quite figure out, you know, how to use this thing and how to really integrate it into their manufacturing cycles. So perhaps, you know, it sounds like something similar, because it requires quite a bit of changes from how you design the product to how you actually, you know, put it in production.
Yes, that's right. There is a very interesting blog, also from Gartner, explaining the hype of the technologies, and the Internet of Things and 3D printing are the ones who are at the highest level, because they can change a lot if the humans are able to very, very fast adapt to this way of thinking. But I can send some links to you if you want, so that you can read the article. It's also a very interesting one.
Yes, that'd be good.
All right, very good. I think then that wraps up our webinar for today. Thank you all for joining us. This webinar will also be recorded, and the slides will be made available, so you'll have the easily clickable links that are mentioned, so you can dive in a little bit further. Join us again in 2 weeks' time when we have another topic on the agenda. You'll receive a nice invitation for that, and please invite your friends, colleagues, and clients to also join us in these webinars, because it's an easy and low barrier way of hearing some interesting things about new technologies. So thank you very much for joining, and have a very good day for the rest of your day.